In this video, we're going to show you how to import a SMA connector into our EMPro tool and set up the red material and ports. So first, let's start a new project. Use the FEM and mil because I know the connector is in inch or mil. So now let's go ahead and import CAD files. And the connector that the vendor provided is in step format. So I'm going to go ahead and import it. And at this screen, you can see the rough dimensions of the connector. And by just looking at it, we know that everything is in inch. So I'm going to select inches. And okay. So here comes the connector. You may say that this is good enough, but look at the connector. Everything is in one lumped object, and it's in one material. So you cannot separate the metal from the dielectric, and you cannot separate the center pin from the housing. So what we're going to do is we're going to separate it into three different objects. And we're going to do that by first select the object and go to create geometry. And we're going to create a sheet body from faces. And then we're gonna, so now there's nothing selected. We're gonna select this one. Once it's selected, the color changes. And you can tell 1 out of 49 faces are selected. Just say OK. And then up here, you can see this is the newly created face that we just generated. We're gonna go ahead and make a copy of that. Copy, and then we're gonna paste it here. Edit, paste. So now we have two of these faces, and you will understand later why we need that. So first, we want to make one of them invisible. And we also want to make the original object invisible. So now you see it's only the face here. And the next step we're going to do with the face is we're going to modify thicken sheet. And I'm just going to make it super big. And I'll say OK. And now I'm going to turn on the original sheet. Um, so now you can see this is the new one, and that's the original one. So in a second, you will understand why I want to do this. So I want to select this and that with the control key. And I'm going to do modify, actually Boolean subtract. And I'm going to subtract the new object that we just generated from the imported object. So if we do that, you can see if I rotate, boom, that center dielectric is removed. And now you will understand why we need the second one right here. So if we set it back, we can use this center one as our dielectric. So the next step is to import some materials. We're going to import that from our material library. And we're going to need, let's say, copper for our conductors. And we're also going to need the dielectric. In this case, it's the Teflon. So we're going to use the PTFT for our Teflon. So we know this is our dielectric. We're just going to drag this dielectric material to this body to assign the material. We're also going to drag copper into the metal part. So now you have copper for the center, copper for the house, and Teflon dielectric in the middle. If I rotate it, you'll see I have that too. The next problem is normally when you want to put a port here, you want the center pin to be on the same plane as the housing. But right now, the center pin is recessed. So in order to put them on the same plane, you want to kind of cut the housing back so that it's aligned. And the way you do that is you can create a cylinder and use that cylinder as a Boolean function to cut that out. So what we're going to do is we'll generate this, And first, I'm going to specify the orientation. I'm going to use, actually in the advanced mode, let's put it in the advanced mode. So we can do simple plane. And then we can select the plane where we want to put the cylinder right here. And let's say we want to make the cylinder super big so that it covers everything. There we go. So we can tell that it's big enough. And then we'll just say OK. And then we'll use these two and do a Boolean subtract, same thing. And actually, we want to subtract the cylinder from the imported object. So here we need to swap order and then say OK. So boom, now everything is on the same plane. And another thing you want to be careful is if you want to import this back into ADS, normally in ADS, if you put it this way, your Z dimension needs to go up. So we need to kind of rotate this so that the Z dimension is going up. What we need to do is we'll right click on this assembly, say modify, specify orientation, and we want to rotate this along the x-axis. So let's put it in the advanced mode, rotate in the x dimension, we'll rotate that by 90 degree. Say done. Now if I put it back, you can tell now Z dimension is going up and X and Y dimension is like this. So now once you import that back into ADS to a board, you will have Z dimension pointing up. The next step is to put a waveguide port right here where your signal comes in. And the way you do that is say new circuit component definition and define a port, and then write as sensors, actually right here, circuit element ports, new waveguide port. And you're going to select a face first. Click this and select this face. And impedance lines, select your negative point, select your positive point, and then apply. So you have your waveguide port here. And another thing we want to be careful is we need to define a property here. And we're going to select that 50 ohm voltage source that we just defined here. And okay, now we don't have any error here. And you have a geometry that you can import into ADS with the correct waveguide port. So that's it. Thank you.